We see solar panels popping up everywhere these days. They're kind of the poster child for our clean energy future. But what if I told you the most important part of this whole story isn't the shiny panels we see, it's what's happening to the ground right underneath them? So just how much land are we talking about here? Well, the Department of Energy estimates that by 2050, we're going to need about 10 million acres for solar. And to give you a sense of that scale, just try to picture the entire states of Maryland and Delaware combined, just completely covered in solar farms. It's a massive amount of land. And here's the real kicker. According to the American Farmland Trust, over 80% of all that new solar development, it's going to happen on agricultural land. Yeah, we're talking about our nation's farms. This huge shift in how we use our land, it forces us to ask a really fundamental question. As we build this incredible clean energy future right on top of our farms, what's actually happening to the soil underneath it all?
Okay, so Section 1, Solar's Unseen Land Challenge. The problem really starts right at the beginning during construction with an impact that's, pretty easy to miss if you're not looking for it.
The Solar Soil Health Guide, it puts it really plainly. It calls soil compaction the most obvious and damaging consequence of solar development. So this is basically the main villain of our story today. All that immense pressure from heavy machinery literally crushing the life out of the ground.
So what does that actually look like? Well, think of healthy soil like a sponge. It's porous, it can breathe, it soaks up water, and it is just teeming with life. Now, compacted soil, that's more like a brick. It's dense, water just runs right off the top, and it chokes out plant roots and all the little microorganisms that are supposed to make soil healthy in the first place.
Which brings us to Section 2, why healthy soil matters. And look, the stakes here are incredibly high. Because soil, it's not something we can just make more of. It's a finite resource.
Healthy topsoil is something we just can't take for granted. It takes thousands of years to form, but it can be seriously damaged in just a couple of seasons. It's this living system that helps prevent floods, it controls erosion, it cycles all the nutrients for our food, and this is critical for our climate, it stores enormous amounts of carbon.
But here's the good news. This doesn't have to be a story about conflict. It can actually be about synergy. And that brings us to Section 3, the Smart Solar Blueprint. Smart Solar asks a really simple but powerful question. What if a solar project could do more than just generate power? It's a whole approach designed to support the farm, the farmer, and, most importantly for our chat today, the soil itself, all at the same time. In this whole approach, it's built on 4 proven, universal principles for soil health. You ready? 1. Minimize disturbance. 2. Maximize soil cover. 3. Maximize biodiversity. And 4. Keep living roots in the ground for as long as possible. This is the roadmap for doing soil right. So, how do we actually put those principles into practice on the ground? Well, that brings us to Section 4, building a better solar farm. See, every solar project has a pretty clear life cycle. To protect the soil, you have to bake these principles into every single stage. We're talking from the initial site assessment all the way through to long-term operations and maintenance. It all starts way before a single shovel hits the dirt, in Stage 1, assessment. This means talking to the farmer, understanding the farm's history, mapping out its drainage, figuring out where the water goes. And crucially, it means taking a baseline soil test, so you know exactly what you're starting with and what you need to protect. Then, in Stage 2, design, smart engineering choices can make a huge difference. To minimize disturbance, you avoid grading the land flat, and instead of pouring these massive concrete footers, you use driven steel piles. The result? A lot less digging and way less disruption to the soil's natural structure. Now check this out for Stage 3, construction. This table lays out the choices so perfectly. On one side, you've got your high-impact methods, letting heavy trucks drive wherever they want, mixing that precious topsoil with the subsoil, not good. But on the other side, you have the low-impact approach, creating designated traffic lanes, storing topsoil carefully, and keeping the ground covered with plants. Believe me, each one of these choices makes a world of difference. And finally, in Stage 4, operations, the job still isn't done. This is all about long-term stewardship. It means actively going in and fixing any compaction that did happen, restoring native plants, and continuously testing the soil to make sure it's not just surviving under the panels, but actually thriving. But what if we could go beyond just protecting the soil? What if we could actually use these projects to improve it? Now, this brings us to our final section, farming the future. And that future has a name, agrovoltaics. It's this kind of radical, amazing idea of integrating agriculture, like growing crops or grazing animals, directly within a solar project. So yeah, this isn't just putting panels on a farm. This is literally farming inside the solar array.
And get this, it's not just some nice theory. A 2024 study found something pretty incredible. They saw that solar sites grazed by sheep tended to have higher soil organic matter and healthier pH levels compared to the sites that weren't grazed. The animals were actually helping to heal the land. All of this, it just shows that we have this amazing opportunity in front of us. It's not about making a choice between clean energy and healthy land. It's about figuring out how to achieve both at the exact same time. Which leaves us with a final, really hopeful question. Can our quest for clean energy also be a way to heal our land?